Hi there, this is Marcin and Andre. We are Sun software engineers working on the Service Domain Manager project. In this video we will explain what SDM, the Service Domain Manager, is about and what you can do with it. Let's assume that the squares represent services and the hexagons are the resources. Then Service Domain Manager is a management infrastructure to manage scalable services and to distribute resources between them. Scalable services are software systems that can be adjusted to different workload profiles through the amount of utilized resources. More resources for a service means that more work can be done. Examples for scalable services are compute clusters, databases, or application servers. Resources are exclusive entities of limited availability. Example resource types are compute hosts, network bandwidth, or licenses. The Service Domain Manager dynamically controls the resource distribution between the services to optimize configurable objectives. Example objectives are resource utilization, throughput, or power consumption. The SDM version 1.0 Update 3 exclusively supports the Grid Engine service domain. Other domains are currently not supported. In the Grid Engine service domain, SDM can be used to provide cluster elasticity. Grid Engine clusters are treated as services and compute hosts as resources. The Service Domain Manager can monitor the workload of the Grid Engine clusters. Depending on the workload, it can rescale a cluster by adding or removing host resources. A typical use case to manage Grid Engine clusters with SDM is elastic multi-clustering. Here is a set of independent Grid Engine clusters share a common set of host resources. If the cluster is idle, we will put green line next to it. If the cluster is busy, a red light starts to blink. Idle clusters offer their spare resources to clusters under heavy workload. By this means, a set of departments can run their own cluster instances with independent configurations but share compute resources of a common data center. The elastic multi-clustering setup has a set of advantages over one with static resources partitioning. Depending on the workload profile, it can result in higher resource utilization and in higher peak load capacities. Another Grid Engine use case is power saving of idle cluster resources. Host resources are removed from the Grid Engine cluster once they run idle. They are moved to a special power saving spare pool where the hosts are switched off. If the workload rises, they are switched on again and re-added to the cluster. Power saving with SDM can significantly reduce the operative costs for data centers, depending on the workload profile of the hosted clusters. A third use case for the Service Domain Manager is Grid Engine clusters with cloud computing elasticity. In this case, SDM is used to rescale a Grid Engine cluster with cloud compute resources. Under heavy workload, the cluster is extended with host resources that are borrowed from the compute cloud. If later in time these hosts run idle, they are returned back to the cloud service. Of course, the set of services can be mixed to get the most out of the different use cases. In this example, we see a set of 3 managed Grid Engine clusters that share a set of local and cloud resources. 3 local resources are running idle in the spare pool service. The default spare pool holds local resources that cannot or should not be power saved. If more resources are required, there are 2 idle local host resources located in power saving spare pool and therefore switched off. They will be switched on again once they are requested. If all 5 resources are requested by the clusters, there are additional host resources available in a managed cloud service that can be utilized as if they were local ones. To manage a service with SDM, a service adapter is required. This service adapter connects to the service and represents it towards the SDM system. A service managed by SDM implies that the corresponding adapter is used. Therefore, service and service adapter are used synonymously in SDM terminology. A service adapter is a configurable entity. It holds the connection details and configurable rules for the resource usage. Important service adapters are the Grid Engine Service Adapter that can be used to manage Grid Engine clusters, and the Cloud Service Adapter that allows to use host resources from a compute cloud like Amazon's EC2. By implementing specific service adapters, SDM can be extended to manage additional types of scalable services. SDM drives the dynamic resource distribution with service-level objectives, or in short SLOs. SLOs are defined per service, and there can be multiple SLOs defined for a single service. Every SLO basically has two responsibilities. First, an SLO can generate resource requests for the corresponding service. The request priority is controlled by a configurable urgency parameter. Second, the SLO assigns usages to requested resources. The usage controls how tight the resource is bound to the service. It reflects how much the service needs the resource. The rule of the thumb is, the request with the highest urgency get the resources with the lowest usage. There is a set of different SLO types available to configure various use cases. For example, the permanent request SLO that tries to get as much resources as possible, or the max pending jobs SLO that can be exclusively configured for Grid Engine services. A max pending jobs SLO generates a resource request if the corresponding cluster is under heavy workload. Here we have an example how SLOs can be used to set up a Grid Engine cluster to work with cloud service and its resources. On Grid Engine side, we have max pending job SLO configured. It will send a resource request when number of pending jobs submitted to Grid Engine exceed maximum value that was set in the SLO configuration. In our case, this number is equal to 10. Permanent request SLO was set up on cloud service side. This SLO sends resource requests constantly, with some time interval. The idea is to gather all unused hosts back to the cloud service. Urgency of this SLO is lower than SLO which is set up on Grid Engine side. It means that requests that come from the Grid Engine will have higher priority than requests sent from cloud service. Let's see now how the system behaves. We'll submit jobs to the Grid Engine. When number of the pending jobs exceed 10, service will start to send resource requests. SDM takes resources from the cloud service and move them to the Grid Engine cluster. Jobs are executed on the cloud hosts. Number of jobs decreases. Max pending jobs SLO does not send resource requests anymore. When jobs execution will finish, cloud host will return to the cloud service thanks to permanent request SLO. Now, when you have seen what the Service Domain Manager is about, you can use it to add elasticity to Grid Engine clusters and see how the service and the resource management works. As a next step, you may want to install the Service Domain Manager by yourself. To learn how to install a SDM system, please continue with the SDM installation video. If you want to see more of the system in action, take a look at our Grid Engine or Cloud Service Adapter videos. Finally, you may want to check the Grid Engine and SDM product pages at www.sun.com/software/sg and the online documentation at wikis.sun.com/display/gridengine. Thank you for watching this video.